on these things are huge. So
okay, actually I might not be able to download it then. So you know what, you can do your dad's screen share of holding up your phone.
Okay, or I could I think I could screen share. Oh, there it is. Let's see if we're feeling bold.
If we're feeling a little crazy. Yeah, we're good to go.
Okay, yeah, there we go.
Are you screen sharing now? No, you're not.
Oh, I could screen. I'll do a test of. Oh no, you probably don't want me to test. Let's. All right.
You can test it, but don't reveal your beautiful photo.
What? No, that's I was gonna test the photo.
Okay, fine. You can test the photo. Hello, everybody who's joining us, and for those of you who are joining us that haven't heard me already say this, reminder that you can change your if you're on Zoom, change the little bar that says all panelists in the chat window to all panelists and attendees, so that you can talk to everybody in the chat and not just John and I. And if you're on YouTube, feel free to comment as well. I know a couple of folks are joining on YouTube today too. John, am I frozen? Are you frozen? Oh, you're back. Are you going to share that photo of NEOWISE?
Oh, hey, there you are. So you were a little photo of NEOWISE here to share, and let me just share. So this is from just my backyard, and our skies are really bad here, so I couldn't. That's another photo. I couldn't see this at all with the naked eye, but it was right over my neighbor's house. And so this is just a few 30-second exposures with my telescope and a designated astronomy camera. And so there's my NEOWISE picture that took me about 2 weeks to finally get it.
Nice.
Okay.
That's pretty solid though. I mean, it looks beautiful. And it's certainly better than anything I've been taking.
I mean, it's actually not a great photo as far as NEOWISE photos go. I mean, some people have just been getting some incredible shots, over the Mont Saint-Michel in France is probably my favorite.
Oh, that's cool. I've seen a couple really nice ones out in BC, and one of our members just took one out in Saskatoon as well, or somewhere in Saskatchewan. And then a couple people mentioning that they're having trouble from Toronto in the chats. And a heads up that if you are in Toronto now, I would guess that it's probably not visible from Toronto anymore. It was for a time, but it's just probably too dim now. For those who are joining and who don't know what NEOWISE is, I will just quickly mention that the comet everybody's talking about right now. It's been exciting because you can see, in some places you can see it with the naked eye, and that hasn't happened in a long time for comets. It was for a long time, and it made it past the sun, and it didn't fall apart, which is what happens a lot with comets. So it's a very exciting thing to have in our sky, and it's pretty cool to be able to see one naked eye. But it is last night at around, I guess this morning at 1:14 UTC Universal Time. So it would have been last night here in Ontario, at least. It came to its closest approach to the Earth, which means that now it is not only moving further away from the sun, it's also moving further away from us. So it's going to be getting dimmer over the next couple days.
And by close, 100 million kilometers or so.
Yeah, it's like close the way that Mars
close.
is close.
Space close, that's really close.
So it's like
close,
relatively close. I'm sorry, I think I'm a little bit I'm coming in and out. So if there's anything that I need to repeat, John, let me know if I cut out at any point.
Sure.
Anyway, so I am going to just quickly touch on NEOWISE as well, and I'll see what happens when I share my screen with this spectacular internet. This is a photo posted by Chris Vaughn, who also hosts Insider's Guide to the Galaxy with Rask. And he's got a photo here of where the comet's going to be tonight. So it's going to be around the toes of Ursa Major, the Big Dipper. So you'll be looking under the Big Dipper's pot, I would say about where the two sides of it, if you extended them in lines, intersect.
And you can see those. I can see the feet from downtown Halifax. These sort of the bottom two stars that are right below the comet there. So that's what I've been using as a guide. But I haven't been able to see it at all without the use of without binoculars. So
right, okay.
So that's probably the case for most people these days who have any light pollution at all. Yeah, binoculars really help.
So I was out in very lucky to have Bortle 1 skies last night, and we did get to see it naked eye. But that's because there is literally no light pollution around us. So it's really unlikely that you'll be able to see that, especially if you're in Toronto. So if you're in Toronto and you're looking for somewhere to go, you'll want to go north of the city, not south of the city, because if you go south of the city, you're looking into the city lights. So you'll want to head north of the city and find a nice big open view to the northwest if you are looking for it. Okay, enough of the comet. Alistair has listed a bunch of extra comets if you are interested. But today we're going to be talking, we're actually not talking about anything that's too terribly difficult to see because
asking where to get the picture.
Am I completely cut out? Did I completely cut out?
Okay, you're broken up there. So you just said something about difficult to see.
So can I get you, I'm going to try switching to a different internet and we'll see if that helps. Can I get you to just quickly talk about, oh, everyone's having different people break up. Okay. Uh-oh. Can someone other than Just Phil let us know who is breaking up and whether or not I should be changing internet? If I'm having trouble, I'll change internet. If John's having trouble, then we'll just kick him out. Just kidding.
Yeah, or I can switch computer. I can switch to a faster computer too, but I'm guessing it's not me.
We've had a couple people saying
in the
that.
Comments, can you just say who is slower or who is more choppy? Is it Jenna or is it John?
Little bit of both, but John, you seem to be more often, I'm afraid. Thank you for everybody who's responding, though.
Yeah, wow, okay. All right, I'll tell you what, I'm gonna go downstairs.
Okay, while you do that, I'll continue about the moon this week. Is that okay?
All right, I'll head out. Thank you.
Perfect. I'm not used to having the show entirely to myself, so you'll have to support me in the chat. So I hope you guys had fun with the targets last week. Let me know in the chat if you did get to see them. I did not get out that much personally because we had a lot of cloud here, but I'm hoping to get out tonight, maybe. We will see. And the targets for this week. So what I was starting to say was the targets for this week are focused a lot more on the moon because the moon, it was just recently new. That would have been on about Sunday this week. And so as it's getting bigger and brighter, it's going to make it harder for us to see the deep sky objects. So I've got a lot more targets for the moon this week. That being said, it is nice to get out and try practicing to see those deep sky objects. And Marie-Claude, you just mentioned that you got binoculars and it's been cloudy nights ever since. That is a curse that happens to all astronomers. Whenever anybody buys either new binoculars, a new telescope, it's cloudy for weeks. So fingers crossed it clears up for you. But for now, we will all blame you for the cloud. So I would recommend this week just going and taking a look at, don't worry, we don't really blame you. I would recommend going and taking a look down in the southern sky. So last week or last couple weeks ago, we talked about looking for M13 and M8. M8 was down in the southern sky. And there's a whole bunch of other stuff down there, which we're going to talk about next week 2 weeks from now, when the moon is new again. So we can really see out through there and see all that cool stuff happening down there. But if you want to go and take a look with binoculars and just kind of poke around down there and see what kind of fuzzy stuff you can find and get a little bit more familiar with those constellations that are down there. And that'll help for the coming weeks. But for now, we're going to talk about the moon over the next couple nights. The moon is a trickier target when we're assigning it in, or when we're talking about it in Explore the Universe context, because the objects that we're listing for the moon during this process, you can only see them on like 1 or 2 nights often. So for example, with craters, you can only see those pretty much in a 12-hour range on the moon, right when the light is hitting, right, really is when the sun is setting or the sun is rising on the moon. John was going to do this demonstration, but all I have is a bar of chocolate. I have nothing round. Let's give this a try. So when the moon hits right on the edge, you'll be able to see all the ridges. So that's right when the sun is setting on the moon or sun is rising on the moon. But when you're shining it from the front like this, you don't get to see the detail as much. as you would if the sun was on the side. So what you're looking for when you're observing on the moon for anything other than the mares, those seas, the dark seas, what you're looking for is sunset or sunrise. So right where on the line between daylight and nighttime, dark and light on the moon. And this week is the first week that we have a crater assigned on the list. So you really only get one shot at it per lunar cycle unless you want to stay up early in the morning and see it again when the light shifts to the other side and the sun's setting. And I'm going to show you what that target is for this week. I just found this, so I was actually looking this up recently to try to keep an eye on where things are. I found this guy's website, derekscope.co.uk, and it has photos of the moon for every day there is, which I have found very helpful. So here's a photo of hold on, let me scoot this down a bit. Here's photos of 9.5 days and 10 days. So you can see a little bit of a difference here. John's back. Hello, John. Hey, buddy, how was the trip downstairs?
Hey. Can you hear me now?
We sure can.
Right.
I'm just going over how to find some of the craters on the moon, and we only have one crater listed for this week, and that crater is the easiest one to see in this photo at 9.5 days. For those of you, when I'm talking about the days on the moon, it doesn't actually translate very well to a calendar or like a normal human being who doesn't track the days of the lunar cycle. So for those of you who aren't keeping track of the lunar cycle, the Copernicus, the 10th day to be able to see Copernicus is around July 30th or 31st. So that's the day to go out and observe for this crater.
Yep. And so you explained why your moon is upside down?
I did not explain why my moon is upside down.
Oh.
I took this from this guy's website in the UK. I'm not entirely sure why the moon is upside down.
Yeah, so it looks like you've got a refractor view there. So that's for people using refractor or Smith-Cassegrain telescopes with a 90-degree diagonal. So that view is, oh, sorry. No, that's the mirror image one. This is a reflector telescope, which is a 180 rotation.
Okay.
I wish I had my props because this is the Newtonian telescope that's sitting on my table there. Yeah. So for people using binoculars, this is upside down. Yeah. So you have to rotate it, but no mirror image by the looks of it. Yeah.
Are you? Yeah, you're right. You're right on that, eh? Yeah.
Yeah.
Okay. The point being, especially for this crater, because this is the first crater that we're doing. So maybe this website is not the best website to go to, but I really liked it because it labeled everything on the line.
Yeah. So that website does have both views. You just have to be careful which one you choose.
I had thought I'd clicked not for that one, but I thought I clicked the binocular. Regardless, whatever works. It's there if you need it.
It's there, yeah.
And if you look on the 9.5, 10th day around July 30th or 31st, Copernicus is going to be like the biggest, most obvious crater that you're going to see. And it's going to be smack dab in the middle of the moon. You can see some other cool stuff. Like this is some people, I think that's called the Lunar Triangle. Is that right, John?
It could be. I use Copernicus as part of the Lunar Triangle.
Oh, okay.
But that's just me. So the coolest thing on the view there, you can't really see it, is the Alpine Valley. So that's on this map, it's right to the right of Plato. I just think that's one of the most beautiful features on the moon. So there's a valley that cuts through those mountains. So Plato is about an inch from the bottom there.
That's Plato.
That's one of my favorites. And yeah, you can see the valley there on the left. It's not
so maybe this on another day would be better. That's not Plato. Where's Plato?
Right now it's the bottom.
There it is. Now it's the bottom.
At the bottom. Yeah, that's my favorite spot on the moon, especially to photograph and stuff as well. I just think it's really pretty.
Cool.
Yeah, and the Ripheus Mountains.
So yeah. Ripheus Mountains, those ones. Yeah. That looks really cool. Too.
I think that looks super cool. To me, it's like an umlaut or an M or something.
Yeah, it's a neat little thing. So this is when we were talking, I was just talking while you were gone about the importance of looking where the terminator is, so where the moon goes from light to dark, because one of the main reason is that it casts long shadows and it really highlights the mountains and the changes in altitude on the surface of the moon. And allows you to see all those really cool craters, whereas if you have light direct on, you don't get to see the shadows from it, and therefore the craters look kind of flat. And so while Copernicus is your target for this time, and you can see it even this is a day after the best of it, you get to see that really dark spot of shadow, but you can see it later as well. So look for that, but then take some time and poke along keep an eye out along that terminator and see what you can find. That's the area that is subjectively the most fun to look at on the moon, but it is well agreed upon that most people like the terminator the best.
The terminators. Well, the latest one where Arnold is a drape salesman.
Oh, stop it, John.
Have you seen the new Terminator where he's selling drapes?
I have not seen any of the
my
Terminators,
word.
so I'm gonna have to believe you that he does sell drapes. It seems like an Arnold Schwarzenegger thing to do.
Yeah. Anyway, if you haven't seen the new Terminator. So this is a really good website. There's a lot on here. For anyone that has, I'm gonna plug my book here. I use only one target per screen in my book for the most part. So if anyone's using this as a guide, it might be a little bit simpler. And then you've got binoculars, refractor, reflector. So it's got all three views depending on which telescope you're using. So hopefully and that's the 50 on the moon book.
Oh, now my internet's unstable. Your book is always fantastic. So John's book, really good. I just sent out the link to that website as well. And so it's in the chat if you need it.
Cool.
So Copernicus is the crater that's on the list. The other lunar targets that we have for this 2-week period, one of them is just a lunar phase. So we do have the lunar phases as targets. I'm going to stop sharing for a sec so you can see both of our faces. We have the lunar phases as targets for the program, and that's just to kind of help you visualize what the lunar cycle looks like and how that orbital motion works. And you can do them all in order if you want to, but you don't have to. I'm not doing them in order for this program. I only tend to do it when I happen to notice that the moon's up, and then I go, oh yeah, it looks like it's it's half full. So that means it's, either first quarter or third quarter, and then I'll just do a little sketch. We have first quarter happening July 27th. So if it's clear July 27th, just poke your nose outside and see if you can see that first quarter, which will be if you're looking at it, the right-hand side will be lit.
Yeah, because tonight we're in the toenail phase.
Oh my God.
Oh my God. Number one.
So you've done this. You've done this to, sorry, you go ahead.
Yeah. So my son calls the crescent phase the toenail. Dad, why is there a toenail in the sky?
That's adorable. They're toenail clippings. You've done this already to Chris Vaughn and I, where you pointed out that that Leo looks like a mouse and not a lion. And now Chris Vaughn cannot see it as anything else. Chris Vaughn did this to me with Wilma on the moon. Now I can't see anything but Wilma on the moon. And now I'm going to call the crescent moon the toenail moon. Yeah.
I mean, why not?
Sure. It helps you remember. So the first quarter is not quite toenail. It's like half-eaten Oreo. But that's on July 27th. Then we've got Copernicus July 30th/31st-ish. And then the last set of targets that we have is for the full moon. And I have yet another picture, not quite full, that I stole from, it's credited by Michael Watson, who's one of our board members. Nearly full, but it has the targets we're looking for. So in this case, we're looking for a couple more lunar mares. So those dark spots, those Cs. Last week, we did talk about, I'm going to get this wrong, Serenitatis.
That's tranquility. Serenity is above it.
Knew I would get it wrong.
Wilma's hair.
Wilma's hair. So we talked about that the last session that we were talking about lunar mares, but it technically was not on the list of things that I assigned for that week. We just talked about it. So we're gonna include that in this week's list as well. Give you a second chance to give it a try. And then we've also got, hold on. We've got, fecunditatis. I don't know what that turns into in English. Fecunditatis, though, is directly under, this is Mare Crisium. Yeah. What do you have it in your book as?
Well, because I never liked the Latin, so I did all English. Oh, you mean fertility?
Oh, okay, that makes sense.
Yeah.
Sure. See fertility then. You can go English or Latin, whatever works. The Explore the Universe document has all Latin, which is why I'm doing it in all Latin, but English works just fine.
Yeah. Fertility is weird because all the other lunar seas are named after how the sea makes you feel or emotions, like rain and storms and moisture and clouds and serenity and tranquility, and then fertility.
Yeah, it's kind of out of place, eh?
Like fish breeding or something. I don't know.
Yeah. Huh. I wonder where they came up with that name. If anyone knows why they named it that, please do tell us in the chat. It's really odd. Anyway, so it's directly, we looked at Mare Crisium almost, I think on our first session, we looked at Mare Crisium, and that's that little, like, it's really easy to spot because it's circular and off to the side. So it's right close to the edge of the moon, and it's kind of detached from everything else. And Mare Fecunditatis, or Sea of Fertility, is below it, right here. It's not particularly well defined, in my opinion. It's kind of lumpy, but Mare Crisium helps you find it fairly easily. And then there's the bonus of continuing along this path. If you want to look for this sea as well, this is this Mare Nectaris, Sea of Nectars, I assume?
Yep.
Yeah. And that's just below Fecunditatis. So it's a little curve around here, and you can look for those two next time you are out. I find them trickier to see than these two big ones because these are so kind of rounded and obvious and clear. And these ones are just kind of like mushy. But they're there. As a scientist, they're very mushy. And so that this full moon will be on August 3rd. So that's the other night to be going out to look at the moon. Okie dokie. I'm going to pull up Stellarium while I just check. Oh, Christopher Green has said that the Sea of Fertility has to do with the myths of the relation between the phases of the moon and human fertility. That makes sense. Interesting. Cool. And if only we had one that was Swiss cheese crater. Okay, so I'm going to bring up Stellarium, I suppose, now. Eh? We'll go and look at the other targets we have, which are not terribly difficult targets this week. They're all mostly constellations. Does that work for you, John?
Yeah, absolutely.
All right, Stellarium it is. Oh no, I've already gone into Stellarium and gone close to one of the targets. So let me zoom out so I don't give it away. Oh, there we go.
I didn't get to do my lunar phase thing, but.
Oh yeah, you missed out. There's John's lunar phase. So this is actually a really fun demo that you can do at home.
It'll look way better at home. Or the way to make it look the best is at sunset. If you've got a little, one of these sewing balls, is go out at sunset and hold it up and then spin in a circle. And your head, or you guys as the camera, you're the Earth. And then you can effectively create all the lunar phases just by turning around.
Yes.
But if you're the Earth and this is the sun, you can sort of do it here. Like it looked a little better on the other computer. But,
because it was lighting the edge of it on fire.
First,
so you can
first quarter, gibbous, and then the reverse.
And you can
anyway.
You can also model it if you have not a general sort of all around light source, but if you have a single bare bulbed light source or like a lamp that you can take the lampshade off, and you can have that act as the sun, and you can be the Earth, and you have the moon in front of you. And then, thank you, Linda, so I tried to demonstrate. I don't have anything round. I tried to demonstrate with my chocolate bar, and it kind of worked. But you can try it yourself, and you can be the Earth, bearing in mind that when you would normally be spinning around clockwise very, very fast, and the moon would be staying in the same spot and moving much slower. So you'll have to pretend to be having nights pass as you go. And then you can hold the moon in front of you and just make sure you turn counterclockwise, because I don't want to say everything in our solar system turns counterclockwise, but most things in our solar system turn counterclockwise with a few minor exceptions, which we can get into later as well. Oh, good. And it's also in the Explore the Universe guide. So if you guys pick that up for this program, that's a neat one to show you how to do it. Harder to do on the internet. I've never tried before. Okay, over to Stellarium, which is what we're going to take a look at tonight. Okay, so this is tonight at just after sunset in Toronto. We do have a thin moon tonight. So if you're interested, a couple people went out last night and saw it. Did you get to see it, John?
No, it was cloudy.
Oh, bummer.
It was too cloudy here.
Too bad. One of the things that I really like about one of the things that I like about astronomers is that they'll always try to catch the moon at as thin a phase as you can get. And if we go back to this time yesterday, the day before, it's this really, really, really thin crescent. And at that point, it was only like 16 hours old or something like that. So you can always try for one of those. It's not on the list of things to get for Explore the Universe, but you can try. It's really fun. Okay.
And you get bonus points for taking a picture of it. among astronomers, in air quotes, people that like to compete with each other. Who has the young? It's called the youngest moon. So, I don't know what the record is, but
it's something like 15 hours. Or maybe 14 or something like that. Maybe it was 9. I'm not sure.
Yeah.
It's very young anyway. But I still maintain that astronomers should have badges the same way that Cubs and Guides do.
Really should.
Good job. You saw the moon at this time.
Yeah.
Okay, so I'm going to scoot us forward to tonight. Everything that I'm going to be showing you now, all the moon phases were specific to days, but everything I'm showing you now will be up for the next 2 weeks. And it will be up for a little ways after that. If you're following along on the Google Calendar, each of the posts tells you how long it's going to be visible for. So you can see it in there. So tonight, let's see what we've got tonight. We talked briefly about this asterism last time. I'm going to scoot out a little bit more. When we were talking about ways to find our way around the night sky. And this is one of the brightest groups of stars that you can see up there. The Big Dipper is, of course, an easy one to find in the night sky. As an asterism, it is part of a bigger constellation that continues along, and that's Ursa Major. But the Big Dipper itself is just like a little group of stars that's easy to recognize. And so we call it an asterism. So we're going to look at the summer triangle. I don't remember the shortcut to bring up the asterisms, but you're going to have to just use your imagination.
Yep.
It's there. It's this triangle here. And this triangle is made up of each of the stars in this triangle is in a separate constellation. There's 3 constellations that are included in this triangle, as well as one relatively close by. I'm not sure if it's inside of it or not. Yeah, there's 2 inside of it, and then one other one over here.
Yep.
So the first constellation that I'm going to show you guys is the one that I think is easiest to find. I don't know about you, John, but what do you think about Cygnus? Do you think Cygnus is the easiest one to find?
I find them all pretty easy. Well, Cygnus has the asterism, the Northern Cross in it. And so that's always handy. And then Vega has the asterism, the diamond right below it. And I always think of, Altair as because it's sort of like 3 stars in a row. I think of it as like summer Orion.
Like these 3 stars here?
Yeah. But now I can't shake the whole, so my wife calls the summer triangle the pizza slice. But most astronomers that are named Dave think of it as Dave.
Is that because Deneb, Altair, and Vega, Dave?
Dave.
Of course. We have several Daves, I'm pretty sure, in the chat right now.
There's lots of Daves in astronomy, and they have their own club, and you have to appreciate it. Yeah.
Oh boy. So I'll start with Cygnus because I find it pretty easy to see because it does have this bright cross here. So when you're looking at the summer triangle, the longest side of the triangle is going to be the one between Deneb and Altair. So Deneb being in Cygnus and Altair being in, I always call this Aquila, but it might be Aquila. John?
I think you're right, but I call it Aquila.
Aquila. Okay. Well, we're going to call it Aquila.
Well, Dave 17.
What's that?
Dave comments. He's Dave 17.
Dave 17. So many Daves.
I mean, I've seen 2 initiations myself into the club, so they're probably at 19 or 20 now.
Oh my goodness. Okay, if there's a Dave out there who's not part of the Dave Astronomy Club, I suppose get in touch and we'll find a way.
Dave says there's 34 in the club now.
Wow.
That's impressive because there's a ceremony.
There's a ceremony.
Yeah.
Oh boy. Well, I think I'm comfortable not being in the Dave Club. Anyway, so back to Cygnus. So we have those 3 stars that are super bright. Cygnus is the constellation that I would argue extends most into the inside of the triangle. And it's got 4, well, at least these 4 stars are really bright, and the head is I find a little bit dimmer. But you get to see that cross nicely in the sky. And if you're in a dark sky area, or even if you're not, the body of Cygnus, this part here, goes directly through the Milky Way. I'm actually going to turn down our light pollution so that you can see. There we go. So you can see that the Milky Way goes along like this, and the body goes right through it. So if you're looking for the Milky Way, or if you can see the Milky Way and you're not sure where Cygnus is, you can use one to find the other. And then you're looking for, I always get this wrong. I always assume this is the head of Cygnus and this is the tail, except I forget that swans have really long necks. And so it's actually the other way around. And then this is his tail and that's his head. And his wings extend to either side. So give him a look. If you're looking at binoculars, have we already talked about this double star? I don't think we have.
Albireo? It's a little small for binoculars, I feel like.
That's fair. Yeah, that's fair.
Yeah, but I mean, it's beautiful on a telescope. Any telescope will split it nicely.
Okay, so if you have a telescope and you're looking for something to do while you're looking at Cygnus, the head of the swan up here is a double star, and not only that, it is a colorful double star. I'm actually going to once again change the size of the stars so you can see them. So I'm not going to tell you what colors they are because that ruins the fun. Okay. But head out there and see if you can spot them and see those different colors. So Cygnus is the main constellation that we're looking, or the first of the constellations that we're looking for. We're also going to look for Vega, which does have this little diamond shape below it. This one's a Lyra. It's Lyra, the constellation. Yep. Yeah.
It's my dog's name.
Yeah, it's the dog constellation. I mean, it looks as much like a Lyra as it does like Lyra. So
yeah.
So there's that little constellation. You will be able to see those 4 stars with some difficulty, even in light polluted areas, but be patient. You can see them, it's just tricky. And then the next star that we have is Altair, and it's part of Aquila, whatever you'd like to call it. I've never actually gone out and looked at this constellation. So I've looked at Altair, but I've never looked at the constellation. So I can't tell you how easy it is to see. John, have you seen it?
Oh yeah. Yeah, it's fairly easy. It's a good guide to like some of the other deep sky objects that are around it, mostly near the tail, away from Altair. Has like, if you just pan by there in binoculars and down through Sagittarius, there's lots of cool stuff like M16, which I believe is the Eagle Nebula, is around that area as well. Yeah. You can use it as sort of a guide, and
lots of cool stuff. And we're going to be looking down here for some other stuff later, but I found this area to be difficult because I'm a baby when it comes to this astronomy stuff. So I saved it for later in the show.
For sure.
But yeah, give Altair a look, see if you can find the 2 stars on either side, and even just, this is meant to be an eagle, and so you're looking for its wings sticking out. Also a comment from Linda, which Linda is absolutely right. This is a swan in Greek constellations, but it is a crane, a sandhill crane, I believe, in Ojibwe constellations and Anishinaabe constellations. And apparently there's a Q&A and I can't get to it. So yeah, there's a lot of really cool constellations up here that have are either part of other constellations from other cultures or have different stories depending on where you're from. And we actually have a book, if you're interested in this sort of stuff. We have a book at RASC which goes over Ojibwe constellations. And it's a fantastic book. It's really cool. It tells lots of the story of the stars, and it's really neat to look up at the stars. I personally really like them because I find the constellations to be more relatable than like Lyres. I've never seen a Lyre in my life. It's much more fun when you're looking at stuff that you recognize. And for example, another one, which I'll scoot us ahead, Pegasus, which is a constellation in Greek culture. It's the winged horse that's upside down. Is a moose in Ojibwe culture, and I've seen moose many more times than I've seen winged horses. So I'm a big fan of learning about the stories of different cultures.
Totally.
Okay, so we've covered those 3 constellations. I have one more target, and and then I have another thing that I wanted to mention, and then that's all we really have today. It's a nice easy week. The target is the double for all of our Canadian friends. This is a double star, and it's a relatively easy to find one. Double stars can be a bit tricky. So you'll want to go to the Lyra. If I say that name loud enough, will your dog come over, John?
Maybe. I think you should try it again.
Lyra, come here. No? All right. Well, if she comes over, you have to show us.
Yeah, for sure. Yeah, I'll try and get her. Here, you talk about double.
Okay, sounds good. You go grab
I gotta beat this though. Let me see
here. So here's Vega, and you'll be able to see, probably, I don't have the binocular field up, probably about this much in the binocular field. And the double is really easy to find because it forms a triangle with Vega and the next closest star. And so that's this little bit here off to the left of Vega, or to the east if you're doing cardinal directions. And the cool thing about this double star is that it's not only a double star, these two stars. I'm actually going to turn the star bubbliness down. There we go. Oh, hello, Lyra. Hi, sweetie. Okay, so everyone look at John's. I'll spotlight his video so you guys can see Lyra. Can you guys see Lyra? What a sweetheart. Oh, she's a good dog. It's my favorite when astronomers name their pets after various astronomy concepts and items up in the sky. Thank you, John, for getting her. Alrighty, so back to the double. So we've got the double at the corner of this this triangle. So not only is it two stars right next to each other, if you zoom in even closer, and for this you'd need a telescope, it's actually each of those stars then is split into two more. So that's a double, and that's a double. Hence the double, the most Canadian of all double stars. And John, in case you wanted to talk, you're still muted. I'm not sure if you did. There you are. So that's, you've observed that one before lots, eh, John?
Oh, lots of times, yeah.
Yeah. I have only seen it once, but the other fun thing to do, and we'll get into these other double stars in a different session. Oh, it's getting dark outside. Is just look at all of the stars that are in Vega, because most of the corners are double stars, most if not all. If you zoom in, you'll see lots of little bundles of stars near each of these bright corner stars. This one's a double. You'll get to see lots of neat little things around there. So you can give that a try as well. There's another double.
With the telescope, you'll see M57 too, the smoke right there, the smoke ring.
Yeah. I saw this for the first time last week. I was really excited about it. That little thing right there.
I've never not been able to see it with a telescope. Like even the smallest telescope, you'll see it. It might be really, I mean, it's really small.
Yeah, I've had trouble with binoculars. I went and looked last night and I couldn't see it in binoculars, but with the telescope, it was way bigger than I was expecting it to be. For those of you who are watching, who are actually doing the Explore the Universe program, this target is not in the Explore the Universe program, which I was very sad about because I think it's really cool.
Oh, Dave just pointed out, Dave 17, that the Lyra is the donut that goes with the double.
Oh my goodness. It is the Tim Horton constellation, really.
It really is.
That's so funny. How isn't that lovely? So yeah, Lyra is a really good constellation to poke around with binoculars, just because there's so many little double stars, and that ring nebula is really something else. I believe, I mean, I haven't seen it, but the Dumbbell Nebula is around here somewhere too, right?
Dumbbell Nebula is at the other side of the triangle.
Oh shoot, okay.
Yeah, but it's close. Like if
I shouldn't have been so zoomed in. There we go. Oh yeah, okay, it's on this side of the triangle, eh?
So the dumbbell is more, I forget the word for it. Like it's
like diffuse?
Diffuse, yeah, that's the astronomer word. So I've been able to get the ring nebula, but not the dumbbell.
Okay.
Because of light pollution.
Okay.
But that's just me in my eyes. Yeah.
Okay, we'll skip the dumbbell for now. If you have the chance, you can poke around.
Or the apple core.
Apple
core nebula.
Yeah, it does look like an apple core. Yeah. It's got that little dense spot right in the middle.
Yeah, my favorite object there is M71, and that's in, so you've got Sagitta, which is the arrow right there.
Yeah.
And you can see M71 right in the middle of those two stars.
Is it that?
Yeah. So
I'm following your instructions instead of looking it up, because why would I look it up? This?
Yeah, because I think that constellation is pretty in general, and then you've got this cluster, and the stars all around there are very dense, and it's neat that you've got that cluster there as well.
Cool.
Yeah.
So that, yeah, I mean, give that a try if you want. I'm not going to go into this how to fit most, because I only just about it right now. I can't. But yeah, poke around, see what you can find in there. I'll also mention, I am.
Yeah. Oh,
it even tells me so. Okay, am I clearer now?
We mentioned, yeah, you're clear now. Someone mentioned the coat hanger again. That's from the previous week, but yeah, that's right in between, Altair and Vega for the most part.
Right here.
on that
Yeah,
one.
so this was one of our targets from last week, was the coat hanger. This little aster is in here. So if you haven't seen that yet, this is a good week to go out and try again, because we're looking at lots of stuff in this general area. So go and take a look. The other, I'm gonna, I think we've covered everything that I'm gonna keep Stellarium up, but I do wanna mention something I'm not sure I've mentioned before, which is why deep sky objects are so much more difficult than stars. So if you're looking, for example, let's go back to the Ring Nebula. If you look at the Ring Nebula, and we click on that, we can see that it is, we can check out its brightness, and its magnitude is 8.8. That nebula is special because everything is so close together. If we went and looked at the Dumbbell Nebula, which I'm not even confident I can find again on my own, somewhere in here, right? There it is. There it is. Yeah. If we look at the Dumbbell Nebula, its magnitude 7.4. So that's actually, I would say, a little bit brighter, actually, right?
Yeah, but like we mentioned before, it's diffuse. So
yeah, it's spread out.
Magnitudes are based on the total amount of light, not the average surface brightness, which would be a more like a star is a point source. Yeah, right. So you know, you're gonna see stars. It's a more linear scale, but you know, you can have nebulas and stuff that you look here and the magnitude seems like, oh yeah, I could totally see that, and then you can't find it. Well, that's because it's really spread out.
So bear that in mind when you're looking at deep sky objects, and if you look at it and you go magnitude 7, easy peasy, no problem. That is actually quite difficult, because that light is spread out over a greater area than, let's say, a magnitude 7 star. That's even magnitude 5 star that's close by. The stars are basically a point source, and so the light coming from it is all from one tiny spot. Whereas with this, I mean, these are about the same. This one's a little bit dimmer, but that, instead of being at a point, it's coming from this whole area. So that makes it much harder to see, which is why deep sky objects are so challenging. And I guess I had never seen the surface brightness listed here before, but I guess that would be much more helpful.
There either, yeah.
Yeah, in terms of that's magnitudes per arc minute squared. I don't have a good idea in my brain of what that actually looks like, but you know, it gives you maybe a better idea.
Dividing the magnitude by the brightness, or by the area of the object.
Right. Okay. So then that should give you, I guess, the brightness at any given point.
Yeah, and the focal, like the type of telescope you're using as well. You know, like a telescope with a high focal length it's harder to see diffuse objects because they're spread over, you know, a larger part of your eye. So yeah. That's
another thing that I found. So even though the Ring Nebula, and I keep going back to it, is not part of the Explore the Universe program, when I found it in my telescope, which I found it immediately, I was amazed. It was so cool. It just kind of like, I pointed my finder scope there and was like, maybe, and then it was right in the middle. But even that, and maybe I hadn't let my eyes adjust to the darkness totally, but I had to look about over here to be able to see it. So I was still using Averted Vision to be able to see that blurry spot.
Yeah. Did you want to talk about Averted Vision just for a second?
Sure, let's talk about Averted Vision because we have the time today. So here's a deep sky object that you're looking at and you're trying to find in the telescope, a fuzzy spot, as it were. When you look at something, our eyes have evolved to see in daylight. So we have a really high density of cones, right where all the light focuses at the back of our eyes, right behind the pupil. And because of that allows us to see color very, very well. But we have fewer rods. Rods are the stuff that allows you just to see light in general. So rods work really well in dim light settings, and cones work really well when there's lots of light around. It works out well for us because even though we can't see as well with dark vision right in the center of our vision, we can see well with dark around that point. So if you're looking at something that's really, really dim, or if you're out at night and you're trying to navigate and you don't have a flashlight, don't look directly at stuff because you won't be able to see it as well. You'll want to look a little bit off to the side and then try to figure out what's over there just from looking away from it, but sensing what's going on in the darkness on that side. And that's called averted vision.
Yeah. And it also helps to adapt your eyes to the dark. So when you're stargazing, it's better not to use iPhones or anything like that because that'll immediately sort of kill your night vision. It takes about 20 minutes of not looking at screens or porch lights or anything like that, and to really bring out the detail. And that, I guess that sort of assumes you've got dark skies already as well. So
and that a good point from Linda as well. If you are in dark skies, and you are looking for NEOWISE, if you so choose. Also, a heads up, comets are on the list of optional targets for Explore the Universe. So if you do get to see it, you can log it for Explore the Universe. But if you're looking for NEOWISE, NEOWISE is a really good object to use averted vision with, because it's dim and it's diffuse and it's spread out over a big area. You can look away from it, or maybe look at the bottom of the Big Dipper, and you might be able to see like a light fuzzy spot that kind of looks like a cloud, and that would be comet NEOWISE.
Yep.
Cool. I'm going to stop sharing because I can't see any of the chat or the questions when I'm sharing. So I'm back to being able to communicate with you guys again. That's it for targets that we have for this week. Next session. So first of all, if you guys have not signed up for the Google Calendar, there's a link on the main website, which is rask.ca/ETU online, which I will send in the chat again. I have set up a Google Calendar, and I have caught up. I've put in every target to the end of this program and when to go out and see, including like reminders for lunar targets and when the days are the best, and that sort of stuff. So if you want to sign up for that Google Calendar, it's a good way to help you remember. And then now, if you guys have any questions about how the program's going, or want to share how your progress is going or anything like that, now would be the time. I am also going to apologize because I accidentally sent out a giant email to everybody being like, I'm sorry you missed the program, except you hadn't missed the program. It was 2 days ago. And that was an accident. I tried to set it up in Zoom so that people who didn't attend this one will be able to send it to get that email, but it didn't work, and Zoom sent it out anyway. So thanks everyone who's been joining us. And if you missed anything, don't worry, it's all on YouTube as well.
and could I, well, people, yeah, so people will be putting their comments in the comment section, I guess, and we'll discuss that in a second. I wanted to announce a few updates to the workbook in response to feedback from you guys. So Jenna specifically, and probably Dave Chapman as well, wanted me to put dates on the work, so a place to record your date, because you don't officially get your ETU certificate unless you provide the date and time with your observation. And that makes sense. And so what I've done, and this is an old edition, but now at the bottom of every page is if you were to get this book on Amazon now, you'll have that date and time spot at the bottom of every page for your observations. And I guess that assumes that you're going to do all 3 observations that are on the page that day. Most of them are they're fairly simple and near each other in the sky, so that makes sense. But yeah, and the other change I did, I added a couple more double stars as well, just to round out in case we were a little short for your ETU certificate. So so that's all in here if you're using this guide as your sort of checklist for the program.
Cool, awesome. Thank you, John, for making those changes.
You're welcome.
And I believe we made those changes to the books that we ordered for the office too, didn't we?
Yep,
did we?
I think so.
Yeah, so we've got some books coming in to the office for sale, but they're significantly delayed. So they will be in eventually, but don't hold your breath. Sorry about that, everybody.
And I think they'll be on sale too, right?
They'll be on what, sorry?
They'll be on sale,
They will be on sale. They will be on sale. So if anyone wants a slightly cheaper book, we do have one. It's a very reasonable price. They should be on sale for around $10.
Yeah.
So that'll be on our website once they're up. So keep an eye on that rask.ca/ETU online for news like that. And to answer the only question that's come in so far, which is what resources can we use to track our observations, we actually were just talking about this. John's book is a really good one. And then we also have a PDF available online, which is the Explore the Universe PDF. And that's the one that we're also printing as a guidebook. I have a copy in another room, and I can run and get it if you're interested. I may do that in a minute. So you can use those two, and you can also use a tape recorder to voice record, or you can write down your observations in like any old notebook, as long as you include a description of the object or a drawing of the object, either one. And the date and time. I also like to include the weather and who I was with and various other elements and whether or not anything interesting happened. So that there's a lot of, so there's a lot of stuff that you can add in if you'd like to. And then finally, there is a question saying, I'm using a 7x50 Celestron binocular, couldn't really see M13 or M8. Any tips? You should be able to with that kind of binocular, I think, John?
It sounds to me that it's either a focusing issue or it's one of three things. It's a focusing issue, it's a targeting issue, or it's a darkness issue. Yeah, so the way you see those objects, you need to know exactly where they are without the binoculars, and you're going to look at them, and then you're going to bring the binoculars up to your face. M13, I like to lie on my back when I look at that, at least at this time of the year, or in a lawn chair that's fairly far back, and then again, just bring the binoculars up to your face after you're already looking at it, and then you have to have already focused your binoculars. And then M8, same way, over there and above Sagittarius, know exactly where it is without the binoculars, and then bring the binoculars up to your face.
I don't personally look at the object and then bring my binoculars up. I look at the brightest nearby star and bring my binoculars up and then star hop from there, just because I know I'm going to get lost otherwise. And at least with bright stars, I can kind of scan around and go, okay, that's brightest. That's the one. Yeah. Whereas, so I'm a little bit, I do that a little bit more. So you can always try that as well. And then you can, and if it's, so it might be a light pollution issue, which is go out of the city a little bit more to try to catch them. And then the last thing that I would say is maybe try the averted vision thing. You never know, it might work for some of them.
Yep.
And then Dave says, Dave, don't worry. So Dave said that 15 by 70 binoculars are pretty shaky. This was a 7x50 binoculars, so they won't be as shaky, but the bigger the first number, the shakier it will be. And a request from Heather, which is, can you tell people how to focus their binoculars, especially the right eyepiece? John, did you happen to bring your binoculars downstairs?
I don't, they're upstairs, but sometimes it switches. So one of the eyepieces has a diopter on it. So what
is a diopter?
It has an official meaning from like the eyeglass world, I feel like. For sure, but it's another thing. So you can focus by twisting the eyepiece on some binoculars, and it changes. Like mine's on the left. Usually I feel like on most binoculars, it's the right eye. And so,
yeah, I think so.
Now I'm tripping as to which is the correct order. So in the book, I have a whole page on it.
You focus with the wheel first, and then you focus with the eyeball next, right?
Yeah, exactly.
Yeah. So there's a wheel on the top. These are my invisible binoculars. There's a wheel on the top of the binoculars that you can turn, and that'll focus the whole pair of binoculars. So you'll want to focus whatever eye does not have the extra turny wheel. So let's say the turny wheel is on the left eye. Close your left eye and focus with the wheel on the right eye, and then open your left eye, close your right eye, focus with that little turny eyeball wheel, and then when you open both eyes, they will both be focused.
Yes.
How you do props when you don't have props.
3-step process. Yeah. Okay. And then if you're using a telescope, the most important thing is to get that finder scope and the telescope pointed at exactly the same spot.
Yeah.
And then the next most important thing is make sure the telescope is focused so that your stars are pinpricks.
Pinpricks for sure. Yeah. And I recommend trying to focus the telescope, or sorry, not focus the telescope, align the telescope in the daytime or when there's a moon. And then that allows you to look at something relatively bright and rather specific. So that helps a lot. I've tried at night and I could do it after I'd had some practice in the daytime, but it took me a little while to figure it out. And then Larry has suggested as an extra suggestion to keep both eyes open when using the scope. And that, I guess, would mean that this eye is more relaxed instead of like the one eye scrunching up, unless you're really good at winking.
I guess you got to practice. Like I've tried that and it's never worked for me. So
yeah, I find it not great for me either, but you can also try wearing an eye patch as an option as well. And then that keeps the night vision really good in one of your eyes as well. Fun fact, that's why pirates wore them. Yep. Someday I'll find an eye patch supplier and we'll get Rask eye patches. I really think it'd be great. Someday. It's not a promise, but I'd like to. Sorry, anyone who's watching. This is not a legally binding agreement.
Yeah. Get planet eyepieces.
That'd be cute. Little Jupiter. Anyway, so that covers all our targets for this week, and we are 5 minutes early, but we haven't got any extra questions, so I think we can send you all on your way.
Absolutely. Well,
all right. Enjoy your observing this week. Have fun with the moon. Hope you can spot Copernicus. We will ask next week if you've seen it, because it's a really fun target to look for. We wish you all clear skies, calm atmospheres, and nice views of comets and the like.
indeed. Thanks, Jenna.
Thank you, John, and thank you for always having a dog and or props. We will see you all in 2 weeks when we're going to be talking more about deep sky objects. Bye, everybody.
Bye.
Take care.